Hello and welcome back to my supercharging, the super slow Swift. But not any supercharging, electric supercharging. And for electric supercharging, we need batteries. So this video is about the internal resistance of batteries changing based on temperature. Internal resistance basically means its ability for the batteries to deliver current. If the internal resistance goes up, that means that they can't produce as much current, and therefore the voltage will go down, and therefore the total power we can deliver to our electric turbo will be reduced. So I wanted to do a test on how the internal resistance would be affected based on temperature. There are some documents about this, and you can find this information on the internet, but I wanted to do it perfectly relative to each other. So I took these three cells. We've seen these cells before. This is a LiPo, this is a LiPo 4, and this is an LTO, and I heated them up, cooled them down, and tested how the internal resistance was affected. How I did that is I put them in the fridge, or I put them in a box and put them on the 3D printer and set the 3D printer to 65 degrees. So 10 degrees centigrade and 65 degrees centigrade. Now, on that LiPo, 65 degrees, super bad idea. Like, just don't even go there. This is not the cell that I used for testing, well, all the testing at 65 anyway. When I heated up a LiPo at 65 degrees, it puffed up like a balloon, like it was going to explode and kill everyone. It didn't though, I must admit, and once it cooled down it reduced its puffiness, but at 65 degrees, was bad call. We also need to remember that at 65 degrees in this test, the batteries aren't being charged or discharged, so like the LiPo, it just would, honestly, it would be a fire really quickly. I'm specifically interested in how they handle the different temperature, because I'm intending on starting the car with some of these, which it could be cold, like 0 degrees centigrade. Although I wouldn't start it off with these, I'm intending to start it off with these LTOs. And since the LTOs are going to be in the engine bay, or at least probably be in the engine bay for starting, I wanted to know how the temperature of the engine bay would affect them. Also, one of my, up until recently, I was going to try the battery pack, the ones that run the e-turbo, in the engine bay as well, and therefore they were going to get hot. So I wanted to know how the internal resistance was going to be affected, because one thing I knew before I even started this, if we heated all of the cells up, their internal resistance would drop, which means they would deliver more current. Yay! But like I said, just don't even go there with LiPo doing this. So we'll move on to the actual numbers and see how much difference temperature affected the internal resistance. Okay, so here we have the cells, LiPo 4, that's in pinky red, maybe salmon colour, obviously because that's the colour of the cell. LTO is blue, and the LiPo 4S is in a grey. So what we have here is, this is the temperature at 27 degrees C, because that just happened to be the temperature of our air at the time when I did that, and it was summer. So the internal resistance in milliohms for the LiPo 4 was 3.77. As per the manufacturers, that's actually outside the spec, as in worse. I do have some which are better within the spec. I did do a follow-up test to see if it made any difference, and it actually didn't make a difference from a percentage change and whatnot. And it is important to point out that is actually pretty bad, as in these are supposed to be amazing cells. If you talk about pulling current, you always have to have a discussion about headway, 38120 HPs, and I can confirm that they are those. But they're not that great. Previously they were considered the bomb for high current, but I wonder if it's one of those things that they used to be amazing but now currently aren't, because battery technology has moved on. There are other videos on YouTube, which I'll post a link to that, also having tested headway 120 HPs, and they've actually done really poorly with current. So, and they work out to be roughly within the same ballpark as my internal resistances. So I mean, basically you wouldn't use these for, well, at least a single set of cells for pulling high current, especially if we compare that to the LTO, which has got 0.31, which is like 10 times better. So the voltage drop will be much lower. 4S, it's important to realize that this is not per cell, that is the total for the resistance for the entire pack of 4, so you could say each cell was a quarter of that. So now we've gone and put them in the fridge at 11 degrees C. Well, that's what their measured temperature was. The temperature of the fridge, you know, it was actually lower than that, but that's what the measured temperature of the cells were after 12 hours of being in the fridge. Yes, I could put them in the freezer at minus 18 degrees centigrade. The reason why I didn't do that was because it doesn't get to minus 18 degrees centigrade outside in Auckland, New Zealand. And I was a little bit worried about what would actually happen to these cells if they got that cold. In the end, I wrecked the LiPo. I didn't want to wreck the LTO. The LTO would have been fine. I actually think that the LiPo 4 would have been fine as well. But anyway, so this is their internal resistance measured at 11 degrees C, and this is their internal resistance change. So, and this is that change as a percentage. So we can see that the LiPo 4 didn't change very much from a percentage point of view, whereas the LiPo changed an awful lot, and the LTO was somewhere in the middle. I've added in the actual values because the percentages make the numbers look bigger than they really are. So while this did have the least percentage change, the actual change in IR was by far the smallest on the LTO. We then put them in a box with no bottom, of course, which was insulated, put it on the 3D printer and heated them up to, well, set the temperature of the bed to, I think it was actually 70 or 80, and then measured the actual temperature of the inside the box and the cells, which was 65 degrees. All of the internal resistances came down, and we can see that as a value and as a percentage change. So the LiPo 4s are, from a percentage point of view, is the most stable in this test. However, in actual values, the LTO is actually changed the least. Now, a comment on the LiPos, I was expecting this to drop way more than 27%, because I was actually measuring the resistance of these as the temperature changed, and these did fly down a huge amount very quickly, but then became very stable at this, well, I guess at this, while the temperature continued to increase. So I think that must have been about the point where they decided that enough was enough, and they started basically puffing as opposed to their internal resistance going down. So yeah, that's really interesting for me. It means that if, as a general rule, it's expected that if we put the LTOs in the engine bay when the car is hot, 65 degrees centigrade for this particular car and in my country is probably fairly realistic. That's where the 65 came from. So their internal resistance would reduce, and by that amount, which means I'll get a bit more current. And likewise, their internal resistance didn't go crazy when it was cold, because ultimately that's the hard part, cold cranking when it's actually cold. Yes, I would have liked to have tried that a little bit lower, but it's probably not going to be a significant amount of change at 0 degrees C to prevent this from working, or at least not on the LTOs. Alright guys, hopefully that was interesting. It was interesting to me anyway. I'll see you on the next one. Bye bye.